Good evening, thank you.
Good evening, Secretary Floriana. I see the recruits are here. Chemistry. The most complicated, yet wonderful science out there. It may seem overwhelming to enter the chemistry world, but we are going to give you all a crash course. With this crash course, you will be well on your way to becoming a secret chemistry agent. But first, you must learn about the chemical and physical properties. From there, you will learn many more of our secrets. You will be inducted into the Undercover Chemistry Society. Welcome, agents. I'm very pleased to have you.
The difference between chemical and physical properties. Physical properties are when substances' characteristics change on its own. Chemical properties are when substances interact with another substance, resulting in a change of characteristics. For example, when you pass an electrical current to water, water decomposes into two substances, hydrogen and oxygen. Therefore, the composition has changed. The chemical property is no longer water. Water H2O equals hydrogen gas H2 plus oxygen gas O2. This is called electrolysis. Electrolysis is the decomposition of water. When it's decomposed by an electrical current through water, it turns back into hydrogen and oxygen. The characteristics of physical properties include melting point, electrical conductivity, and density.
Focusing primarily on the distinction between a substance and a mixture, we must define a substance as matter with a definite composition and distinct chemical properties, such as oxygen or fluorine. Mixtures are simply those substances when in combination with one another. Two types of different mixtures. When referring to mixtures, a homogeneous mixture refers to our inability to detect and see the various components that make up the mixture. When referring to a heterogeneous mixture, the various components that make up that mixture can be seen. Mixtures can occur on a microscopic scale, even in the form of compounds. For example, if an electron is completely transferred between atoms, resulting in a positive ion and a negative ion that then attract to each other, this is called an ion. Salt is a good example of this. The sodium atom steals electrons from the chlorine atoms, and then the charged ions attract together in a big crystal lattice.
Writing and balancing chemical equations can be really simple if you follow these easy steps. And so this is a really basic synthesis reaction. I've got sulfur and oxygen. And if we remember about sulfur and oxygen, they don't like to be alone. Sulfur always exists in eighths, and oxygen always exists in tubes, right? Our product is SO2. Now you'll notice these little blanks that I've put in front of each. That's for when I balance, right? And so in order to balance an equation, I need to make sure that I have the same number of atoms of each element. So I'm going to give myself a little diagram here, a little chart, so I can count how many of each atom I have on my reactant side and on my product side. So for sulfur, I have 8 sulfurs. And for oxygen, I have 2 oxygens. And on my product side, I have 1 sulfur and I have 2 oxygens. Okay? So oxygen is happy, but sulfur isn't. So how can I make my reaction happy? Well, how do I turn 1 into 8? That's really easy. I'm going to multiply by 8. It's going to give me 8. So I'm going to put an 8 here. But now I've changed my number of oxygens, because I've also multiplied my number of oxygens by 8, right? Because 2 times 8 gives me 16 oxygens. So I'm going to come over here to my reactant side, And I'm also going to put an 8 in front of this oxygen so that this oxygen is balanced and this oxygen has enough atoms as well. So I've got 2 times 8, and that gives me 16. So let's double check. I've got 8 sulfurs, 16 oxygens, 8 sulfurs, and 16 oxygens. My reaction is balanced. My atoms are happy. These coefficients are really important because when you're doing stoichiometry, you need to know how many moles of each one of these you have so that your reactions will balance if you're trying to find a limiting reagent. So my coefficients my atoms are all happy, my coefficients are happy, everything is nice and balanced. But this is particularly important if you're doing stoichiometry because you'll need these coefficients in order to do the stoichiometry problems like finding a limiting reagent. So, happy balancing. Valence electrons are the electrons that are used in bonding. And to figure out what the number of valence electrons is for any particular element can be pretty simple if it's a main group element. So if we look at the periodic table, and we look at our main group elements, which are the tall ones on our periodic table, the group 1 elements have 1 valence electron, group 2 has 2 valence electrons, 3 has 3, 4 has 4, 5 has 5, 6 has 6, 7 has 7, 8 doesn't have any valence electrons. These are our noble gases, and if we remember, our noble gases have a full octet and they don't like to share any of their electrons, right? So the number of valence electrons means the number of electrons that can be used for bonding. Now for these guys in here, our transition metals, it's a little bit more difficult to figure out. But if we remember our orbitals, then we can figure out our valence electrons because it's simply the number of electrons in our s orbital plus the number of electrons in our d orbital. So for example, chromium has 2 electrons in its s orbital plus 1, 2, 3, 4 electrons in its d orbital, giving chromium a total of 1, 2, 3, 4, 5, 6 valence electrons. So see, figuring out valence electrons can be pretty simple.
Let's learn about gas pressure and how to measure it. You may be thinking, can we even measure gas? Yes, we sure can. Gas particles move rapidly and randomly in a container. The speed at which they bounce off that container is what creates the pressure. The pressure is what allows an individual to blow up a balloon or for a tire to expand when air is put in it. A balloon, once it has been blown up, for example, will collapse when the air is let out. And that is because the pressure inside the balloon is unequal to the pressure outside the balloon. Anytime the outside pressure is uneven, objects tend to get crushed from unequal pressure. Also, without the inside pressure, there is nothing to keep the balloon, allow the balloon to keep its size. Atmospheric pressure is the pressure that atmosphere evenly displaces in the environment. Neat fact, atmospheric pressure is responsible for why someone can use a straw.
With the topic of energy. Kinetic energy is defined as the energy an object displays or possesses because of some kind of motion or action. Potential energy, on the other hand, is the energy an object possesses or displays by virtue of its state of rest.
Internal energy, or E, of a system is the sum of potential and kinetic energy of each particle in said system. Internal energy changes when reactants become products. Delta E refers to the final state of the internal energy, E final minus its initial state, E initial. A system is only capable of changing its internal energy in 2 ways: releasing energy in a transfer to the surroundings or by absorbing it. When energy is being released, E final is less than E initial, causing the change in E to be less than 0. When it is being absorbed, E final is greater than E initial, causing the change in E to be greater than 0. Delta E is the total change in a system's internal energy, and it can be found by adding work, or W, and heat, or Q. Energy transferred into the system is positive, and anything transferred out is negative. When energy is transferred as heat only, it is represented by the formula delta E equals Q plus 0 equals Q. When it is transferred as work only, it is represented by delta E equals W plus 0 equals W.
Redox reactions. Redox reaction is a type of chemical reaction that involves a transfer of electrons between two species. An oxidation-reduction reaction is any chemical reaction in which the oxidation number of a molecule, atom, or ion changes by gaining or losing an electron. Redox reaction, some of important terminology that we have to know is what an oxidation means. Oxidation means the loss of electrons, and reduction is the gain of electrons. Here's one example for redox reaction. We have magnesium and oxygen. Both of these reactants are in their elemental state, so oxidation number is going to be equal to 0. After the reaction occurs, magnesium oxidation number is going to equal +2 and oxygen is going to be equal -2. The sum of these two is going to equal to 0. Magnesium in this example is being oxidized since it loses electrons and gives them to the oxygen. Oxygen is going to be reduced. Therefore, oxygen is going to be the oxidizing agent, and magnesium is going to be the reducing agent.
The wave properties of electromagnetic radiation are frequency, wavelength, amplitude, and speed. Frequency is defined by the letter V, and it is the number of complete waves that pass a given point per second. Wavelength is defined by the Greek letter lambda, and it is the distance between the crest of one wave and the crest of another. Amplitude is the height of the crest of a wave.
Now, comrades, you know all of our secrets. Will you take this training seriously, agents? If not, I will destroy you like my protein bar.